All right, in this last portion of notes on finding the surface area and volume of triangular prisms, we are looking at triangular prisms whose bases are equilateral triangles. Now, before we get into an actual example that we have on our paper, we need to review for a moment what happens with special right triangles. I've got an equilateral triangle drawn here, and we've talked about this before, that if we let this side have some unit 2 times x. Now, that could be that 2x is some even number, or it might be that it's an odd number, but ultimately, each side has a length of 2x. Now, if I'm going to try to find the area of this particular triangle, then that would mean that since this side is 2x units long, that this base edge here has a length of 2x as well. Now, the height of the triangle would be required to find the area. So if I draw the height into this equilateral triangle, I know that it's going to divide this base segment, this bottom leg, into 2 congruent parts. And since the whole thing was 2x units long, that means each of these will be x units long. Now, you may remember us doing something similar to this when we talked about 30, 60, 90 triangles. Remember, a 30, 60, 90 triangle is determined by taking half of, like we have here, an equilateral triangle. In an equilateral triangle, the original angles are 60 degrees each, which means this 60-degree angle up here at this top vertex has been divided into 2 congruent parts by the height of that triangle, which means each of these would have a measure of 30 degrees. Now, in a 30, 60, 90 triangle, the leg that is the shortest, the one that's opposite the 30-degree angle, is always half of the hypotenuse, which is the side of the original equilateral. And if I take that shorter leg and multiply it by the square root of 3, it gives me the length of the other leg, which means this height of the triangle is whatever that short distance is times the square root of 3. So let's say I have an equilateral triangle. Do a poor sketch of one. Ooh, that's a really bad equilateral triangle, but we're just playing, so it'll work for a sketch. So let's assume then that I have a side length of 20 units here. When I draw the height into the triangle, I know that it divides this side that was 20 units long into a side 10 units long and a portion 10 units long over here. And due to that 30, 60, 90 relationship, if I take this 10 times the square root of 3, that'll be the length of the height. Now, you could go this process or do this process using the Pythagorean theorem. That's the way we originally derived this particular value when we studied special right triangles. And you can do the same thing here on these examples. Use the Pythagorean theorem. It's just quicker if you know your special right triangle relationships to find the length of that height using those 30, 60, 90s. All right, so in this case, let's look at now our triangular prisms. In the case here, we have a base that is an equilateral triangle, 16 units on each side. So I'm going to go ahead and, you saw how bad I am at sketching equilateral triangles. Use my little geometer here. Draw myself an equilateral triangle. 16 units long on a side. So as we just discussed, when we draw the height in, divides this side of 16 units into a length of 8 and 8, which makes the height 8 square root 3. And that comes in very handy when it comes time to find the area of that base. So in this case, the area of the base, the area of the triangle, is 1/2 of the bottom segment 16 times the height of the triangle, 8 root 3. And we know that the square root of 3 is an irrational number, which means it doesn't have a decimal that's going to work very well for us. We'd have to round it. That decimal is going to go on forever. So in this case, what I'm going to do instead is multiply just the 1/2 times the 16 times the 8. And we've done that before when we dealt with special right triangles. Half of 16 is 8 times 8 is 64. So this is 64 times the square root of 3. If I were to go to a calculator and type that in as 64 times the square root of 3, it's going to give me a very long decimal. And I don't want to round that decimal here because this isn't the final answer I'm looking for. Now let's find the perimeter of the triangle. We have 3 sides, 16 units long each, so 16 plus 16 plus 16 gives us a perimeter of 48. As we've discussed in the previous videos and as well as other videos, We now have our capital B value and the capital P value. The other value that we need for a prism is the length of the height of the solid. The height of the solid is the distance between the bases, in this case the distance between the triangles. So between this triangle and this triangle is a height or a distance of 13 units. So 13 represents the H value that we're searching for the height of the solid. All right, so for the surface area, 2 times the area of the base plus the perimeter of the base times the height of the solid. 2 times 64 square root 3 plus the perimeter of the base, 48, times the height of the solid, 13. And then you're ready for your button pushing. Make sure that if you have the type of calculator, like I do, where when I open a square root, it automatically opens a parenthesis, that you close that parenthesis immediately after the 3 before typing in the plus 48 times 13. So in this case, 845.7. In the absence of a label, we use units squared for an area. And that takes care of the surface area. Now the volume. Volume is the area of the base, B, times the height. In this case, 64 square root 3 times the height of the solid, 13. 64 square root 3, close that parenthesis, times 13. 1,441.07 units cubed. All right, so at this point, I would advise you to pause the video and attempt to find the surface area and volume of number 6. And then you can restart it and see what the solution is when you're finished. Okay, so assuming you've had time to do that, let's look at our equilateral triangle here again. I'm going to use my little tool and draw myself a triangle. All right, so my equilateral triangle in this case has a side length of 8 units, which means when we draw in the height of that triangle, it makes this segment 4, and the height becomes 4 root 3. So the area of the triangle, 1/2 of the base edge, remember to use the entire base, 8, times the height, 4 root 3. There again, the square root of 3 is irrational, so we're just going to multiply 1/2, 8, and 4. Half of 8 is 4, times 4 is 16, square root 3, for the area of the base. The perimeter of the base, we have 3 sides, each 8 units long, so 8 times 3, 24 units. For the surface area, 2 capital B plus capital PH. 2 times 16 root 3 plus 24 times the height of the solid. The height of the solid is the distance between the triangles, 11. 2 times 16 square root 3, remember to close your parenthesis. 319.43 units squared for that surface area. For the volume, take the area of the base times the height of the solid. 16 square root 3 times 11. 304.84 units cubed. And that completes our video on finding the surface area and volume of a triangular prism whose base is an equilateral triangle. It also completes our notes now on triangular prisms. If you have any questions, let me know.